So today is the last lesson on trigonometry. I wrote on the board that we're going to have our test on Thursday. So tomorrow we'll do some review. I will hand out the review assignment today, as well as the homework assignment, in case you wanted to start working on the review assignment, because remember, those are always due for marks. Okay, and then we just have one chapter left after that, measurement, and then we'll see. Hopefully we have a few days to go back and review some of the stuff that we looked at early on in the course. Okay, but we're going to finish off finding missing sides or missing angles in right triangles.
Number, but A is equal to 10.7. A is equal to whatever B. We're asked to solve the right triangle shown below. Give the lengths to the nearest tenth. So when they say solve the right triangle, we can assume that they're saying, hey, figure out the lengths of all the sides. So whatever A is equal to, whatever B is equal to. And also, what are all the angles of the right triangle? They've given two of them. We might have to figure out this third right over here. So there's multiple ways to tackle this, but we'll just try to tackle side XW first, try to figure out what A is. And I'll give you a hint. You can use a calculator, and using a calculator, you can use your trigonometric functions that we've looked at a good bit now. So I'll give you a few seconds to think about how to figure out what A is. Well, what do we know? We know this angle y right over here. We know the side adjacent to angle y. And length A, this is the side, that's the length of the side that is opposite. That is opposite to angle y. So what trigonometric ratio deals with the opposite and the adjacent? So if we're looking at angle y, relative to angle y, this is the opposite, and this right over here is the adjacent. Well, if we don't remember, we can go back to SOHCAHTOA. Sine deals with opposite and hypotenuse. Cosine deals with adjacent and hypotenuse. Tangent deals with opposite over adjacent. Opposite over adjacent. So we can say that the tangent of 65 degrees of that angle of 65 degrees is equal to the length of the opposite side, which we know has length A, over the length of the adjacent side, which they gave us in the diagram, which has length 5. And you might say, well, how do I figure out A? Well, we can use our calculator to evaluate what the tangent of 65 degrees are, and then we can solve for A. And actually, if we just want to get the expression explicitly solving for A, we can just multiply both sides of this equation times 5. So let's do that. 5 times 5. These cancel out, and we are left with, if we flip the equal around, we're left with A is equal to 5 times the tangent of 65 degrees. So now we can get our calculator out and figure out what this is to the nearest tenth. Get my handy TI-85 out, and I have 5 times the tangent. No, I didn't need to press that second right over there, just the regular tangent of 65 degrees. And I get, if I round to the nearest tenth, like they asked me to, I get 10.7. So A is approximately equal to 10.7. I say approximately because I rounded it down. This is not the exact number, but A is equal to 10.7. So we now know that this has length 10.7 approximately. There's several ways that we can try to tackle B, and I'll let you pick the way you want to, but then I'll just do it the way I would like to. So my next question to you is, what is the length of the side YW, or what is the value of B? Well, there's several ways to do it. This is a hypotenuse, so we could use trigonometric functions that deal with adjacent over hypotenuse or opposite over hypotenuse. Or we could just use the Pythagorean theorem. We know two sides of a right triangle. We can come up with the third side. I will go with using trigonometric ratios, since that's what we've been working on a good bit. So this length B, that's the length of the hypotenuse. So this side WY is the hypotenuse. And so what trigonometric ratios, and we can decide what we want to use. We could use opposite and hypotenuse. We could use adjacent and hypotenuse. Since we know that xy is exactly 5 and we don't have to deal with this approximation, let's use that side. So what trigonometric ratios deal with adjacent and hypotenuse? Well, we see from SOHCAHTOA cosine deals with adjacent over hypotenuse. So we could say that the of 65 degrees cosine of 65 degrees is equal to the length of the adjacent side, which is 5, over the length of the hypotenuse, which has length b. And then we can try to solve for b. You multiply both sides times b, you're left with b times cosine of 65 degrees is equal to 5. And then to solve for b, you can divide both sides by cosine of 65 degrees. This is just a number here, so we're just dividing. We have to figure it out with our calculator, but this is just going to evaluate to some number. So we can divide both sides by that, by cosine of 65 degrees, cosine of 65 degrees, and we're left with b is equal to 5 over the cosine of 65 degrees. So let us now use our calculator to figure out the length of b. The length of b is 5 divided by cosine of 65 degrees. And I get, if I round to the nearest tenth, 11.8. So B is approximately equal to, rounded to the nearest tenth, 11.8. So B is equal to 11.8. And then we're almost done solving this right triangle. And you could have figured this out using the Pythagorean theorem as well, saying that 5 squared plus 10.7 squared should be equal to b squared, and hopefully you would get the exact same answer. And the last thing we have to figure out is the measure of angle W. Angle W right over here. So I'll give you a few seconds to think about what the measure of angle W is. Well, here we just have to remember that the sum of the angles of a triangle add up to 180 degrees. So angle W plus 65 degrees, that's this angle right up here, plus the right angle, this is a right triangle, they're going to add up to 180 degrees. So all we need to do is, well, we could simplify the left-hand side right over here. 65 plus 90 is 155. So angle W plus 155 degrees is equal to 180 degrees. And then we get angle W, if we subtract 155 from both sides, angle W is equal to 25 degrees. And we are done solving the right triangle shown below.
Okay. Bless you. So these examples want us to find the missing side or angle, round to the nearest tenth. And for question 1, you're looking for the value of x. So remember, our first step, always label the sides of the triangle. The side across from the right angle is always the hypotenuse. That never changes. But the opposite and the adjacent side will change. It just depends what angle you're working with. So you're looking to find the value of x, which is the hypotenuse. We're going to use a 23-degree angle because we're given that. The side across from that is the opposite. Third side is the adjacent side. So that's always our first step. Label the sides of the triangle. Then figure out which two sides are being used. In this case, it is the the opposite and the hypotenuse. We're given the length of the opposite. We want to find the length of the hypotenuse. We're not given the adjacent, not asked to find it, not using it. So SOHCAHTOA tells us what ratio we need to use in this case. The ratio that uses opposite and the hypotenuse is the sine ratio. And the SO part tells us that sine is O first, H second, opposite on top, hypotenuse on the bottom. So this is how we write our equation. The sine of the angle, 23 degrees, and the order matters. The SO part tells us that it's opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. Must be in that order. So on the video, he said, well, to get x by itself, what he did is he multiplied both sides by x, which is the same thing as what we've been doing, and that is cross multiplying. You see, when you multiply both sides by x, you're going to have an x times the sine of 23, and on the right side, the x's would cancel. So you just have 6.4. You'd have x times the sine of 23 on one side equaling 6.4 on the other, which is exactly what you get if you cross multiply here. X times the sine of 23 degrees equals 1 times 6.4. So that is the exact same expression you would get if you multiply both sides by x. It is the same as cross multiplying. However, in this case, we have one extra step to do to get x by itself. We need to divide both sides by the sine of 23 degrees. You see the x and the sine of 23 are hooked together on the left by multiplication. So to separate them, we have to divide. So now on that left side, the sine of 23's will cancel, and you have x by itself. And we're asked to round everything to the nearest tenth. Make sure that we are in degree mode, and my calculator is not, so I need to fix that. And then we'll have 6.4 divided by sine of 23. So 16.4 is the approximate answer for x, and that would be in inches because the opposite side is in inches as well. Right, for question 2, we want to find the angle A. That's where that arc is. So that's what we want to find. We start with labeling the sides of the triangle. Side across from the right angle is the hypotenuse. The side across from the angle we're working with, in this case we're trying to find, is the opposite. Third side is the adjacent. Right, so there's our first step, label the sides. Second, which two sides are we using? Well, we're given the adjacent and the hypotenuse, so those are the sides we're going to use. We're not given the opposite side. We're not asked to find the opposite side. We're asked to find angle A. And the ratio that uses adjacent and hypotenuse, if we look above, that is the cosine ratio. That's what the ca part tells us. Cosine is adjacent over hypotenuse. The cosine of the angle A, is the adjacent over the hypotenuse. And so yesterday we saw how you find a missing angle using the calculator. Angle A would be found by going cosine to the negative 1 of 16 on 25. Which we will round to the nearest tenth because that's what it asks us to do. Okay. Okay. So we can go to our calculator and go second function cos. Damn it. There we go. Okay, so that gives us an answer of 50.2 degrees. second function cos of 16 on 25. Okay? Okay, is it all good? What's the problem? Second function cos of 16 on 25. Pardon me? 16 divided by 25. Bring your calculator here. Okay, you can start working on number 3, everyone, and we'll check it. On this calculator, you might have to go 16 on 25 first. Get that as a decimal, and then go second function cos. Nope. Try it again. Yeah, you might have to use brackets on this one. Like actually physically put the brackets in. Okay. Because most calculators, when you put the cos to the -1, a bracket opens up, but this one doesn't. So you have to put the bracket there.
All right, thank you.
Yeah. Okay, question 3. You want to find the value of x. Now in this case here, the only angle we're given is a 9-degree angle here in the bottom left. But we've said before that you cannot use a 9-degree angle with SOHCAHTOA. Okay, Brooklyn? Brooklyn? You need to take both earbuds out. And you need to stay with us. So we don't have one of the small angles here. But we've got two sides of a right triangle. When that happens, you can always find the third side, remember, by using Pythagorean theorem. Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse, the side across from that angle. That is 6.6. Okay? So C is the hypotenuse, A and B are the two legs of the triangle. It doesn't matter which one is A and which one is B. So if I say that X is A and 5.4 is B, I would get X squared plus 5.4 squared equals 6.6 squared. Remember, with Pythagorean theorem, the sides are all squared when you use Pythagorean theorem. And so to get the x squared by itself, I would subtract 5.9 squared from both sides. They'll cancel on the left, and we'll have x squared equals, on the right side, it's 6.6 squared minus 5.9 squared. Try that again. You're right, it is 5.4. Thank you. Okay, I'm going to kick someone. Jan? I'm going to kick someone. It might. You're the closest. Okay, so that gives us 14.4. That's what x squared is. Then to find x, we have to take the square root of both sides. To get rid of the squared, we take the square root of both sides, which gives us approximately 3.8 for x, which is a reasonable answer. It has to be less than 6.6 because the hypotenuse is always the longest side. So our answer is reasonable. Because on the diagram it says x. That's why. All right. Question 4. We want to find the angle in the bottom right-hand corner. So that's the Greek letter gamma. But we start with labeling the sides of the triangle. Side across from right angle is the hypotenuse. Because we want to find that angle there, the side across from it is the opposite. Third side is the adjacent side. And in this case here, we're going to use the opposite and the adjacent, which is the tan ratio. The tangent of the angle gamma equals, and the definition of tangent is that it's O first, A second. Opposite on top, adjacent on the bottom. So to find out what the angle gamma is, we do the inverse tan. Second function tan of 42 on 45. So second function tan, 42 on 45. So 43 degrees, rounded to one decimal, would be 43.0. Rounded to the nearest tenth. 43.0. Okay? So let's skip down to question 7. There is nothing indicated there for question 7. So let's say we want to find the missing angles, because we only have to find 2 angles here, and then we have the triangle solved. So let's say you want to find angle C first. We start by labeling then the sides of the triangle. Side across from right angle is the hypotenuse. Because we want to find angle C first, the side across from that is the opposite. Third side is the adjacent side. So because I have all 3 sides, I can use any 2 that I want. It doesn't matter. I'm just going to decide to use the opposite and the hypotenuse, which is the sine ratio. The so part tells us that the sine is opposite divided by hypotenuse. So the sine of angle C would be 6 on 10. And then to find out what C is, we have to go sine to the negative 1 of 6 on 10. So second function sine of 6 on 10 would be 36.9 degrees when we round it. Okay, so that is the measure of angle C, 36.9 degrees. And we can now find out what angle A is, because we have 2 angles of the right triangle. And every triangle adds up to 180 degrees. But we already have 90 degrees at angle B, so the other 2 angles must add up to 90 as well. So to find angle A, I can just simply go 90, take away 36.9. So 90 take away the previous answer. Which will be 53.1 degrees. Okay? And then for question 8, we want to find little x, little y, and angle A. So again, essentially we are solving the triangle. We're finding all missing sides and all missing angles. Let's start by finding angle A first. Again, there is no little box in the corner of the right angle for this triangle, but obviously you can tell by looking at it that that bottom right-hand corner is the 90-degree angle. And then to find angle A, we can go 90 minus 45 degrees. Three angles of every triangle add up to 180. Because this is a right triangle, we've already got 90 degrees. So the other two angles must add up to 90 as well, so they add up to 180. So it turns out this is an isosceles triangle. Two sides are equal because two angles are equal. Angle A and the angle at the top are both 45 degrees. So whenever you have an isosceles triangle, that means two angles are equal. It also means that two sides are equal in length. Okay, but let's continue on and we'll see what we get for the length of the sides. We only have one side right now, so we can't use Pythagorean theorem. We're going to have to use a trig ratio in order to do this. Okay, so let's say, well, first if I label the sides of the triangle, there's a hypotenuse. Let's say we're going to use that angle there, 45 degrees. The side across from that is the opposite. Third side is the adjacent. So in this case, if I want to find x, I would use the opposite and the adjacent, which is the tan ratio. The tangent of angle 45 degrees equals, and the TOA part tells us that it's opposite on top, adjacent on the bottom. When you cross multiply here, 1 times x will equal 8 times the tan of 45 degrees. So 8 times the tan of 45 equals 8. And the reason for that is because the tan of 45 degrees is actually 1. If you take just the tan of 45 degrees, it is 1. And so really you're going 8 times 1 here, which is 8. As we said, this is an isosceles triangle. As soon as two angles are equal, the sides across from those angles are also equal. Okay, Christy? So this side here is 8 as well. And now we can find the hypotenuse if we want by using Pythagorean theorem. Remember, Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. In this case, that's what we're trying to find, little y. So the other two sides are the legs of the triangle, which are both 8. And so on the left side, if we go 8 squared plus another 8 squared, that's 128. And then to find out what y is, we take the square root of both sides. So it's the square root of 128. Approximately 11.3. Okay? All right, so that's it for trig. So I'm going to hand out the today's assignment as well as the review assignment. I will post the solutions to Google Classroom for 6.7 assignment so you can check your work. So remember, our test is on Thursday on this stuff. Okay? Test Thursday.